Hello friends, welcome to Math Solution Academy. Now we talk about NBHM Algebra in 2016-18. The first problem is let G be a group. Which of the following statements are true? The statements are the normalizer of a subgroup of G is a normal subgroup of G, the center of G is a normal subgroup of G, and the third option is if H is a normal subgroup of G and is of order 2, then H is contained in the center of G. Now we check the first option. If we take G equal to S3 and H equal to a group generated by 1 2 element, then this is E and 1 2 because order of 1 2 equal to 2. Now normalizer of H becomes G belongs to S3 such that G inverse equal to H, and in my previous lecture I proved it that this is generally H, and since H equal to this, and we prove it that H is not a normal in S3. Take an element 1 3 belongs to S3 and 1 3 H, this becomes 1 3 H equal to 1 3 into E into 1 2, where E is an identity element in S3, and this is 1 3 1 3 1 2, and this is generally 1 3 1 2 3. Now we compute H into 1 3, which is a right coset, and this became E into 1 3, E into 1 2, this is 2 into 1 3, and this is 1 3 1 2 1 3, and this is 1 3 and 1 3 2. So you see that H in 1 3 not equal to H into 1 3. So hence H is not normal in S3, but NH, and this is equal to H, is a normalizer of H in S3. So the first option is false. This is not correct. So now we check the second option. The second option told that the center of G is a normal subgroup of G. Let K equal to Z of G, where ZG is the center of G, and this is a set. Say G belongs to Z such that GA equal to AG for all A belongs to G. So center of G is those set which is commute with every element in G. Now we prove it that ZG is a normal. Suppose P belongs to capital G and say a small k belongs to capital K, that is ZG. So we test the normality test, and so P inverse, this became, and this we take, then this became KP, since KP P inverse, since K belongs to capital K, and this is generally ZG. So commute with P, and this is became K into from associative from associativity in a group, and this is generally K into E, and this is K. Generally this belongs to capital K. So since P is an arbitrary element, and so for all P belongs to G and K belongs to K, these imply P inverse belongs to capital K. So therefore, so K is a normal subgroup in G. So the second options is true. Now we prove the third option is also true. That the third option became, if H is a normal subgroup of G and is of order 2, then H is contained in the center of G. So the third options, so let H, since order of H equal to 2 T, then let H belongs to two elements, say A and T, where A not equal to E. Since order of H equal to 2, and we take this set as this. Now take an element. Say S belongs to G. So SH becomes S into E into here A, and this is S and SA, and HS equal to EA S, and this is S, and by the given condition, H is normal in G. So SH equal to HS, and this became S into SA, sorry, S comma SA, and this is generally S, and if we comparing both sides, so therefore SA equal to AS. Otherwise, if this is otherwise if SA equal to S, then this imply that A is an identity element, which is not true. So this is wrong. So SA equal to AS hold, and since S is arbitrary, so SA equal to AS holds for all S belongs to G. So therefore A belongs to ZG and the center of G. And since H is contain just two elements, E and A, so this is generally subset of ZG. Hence the third option, H is contained in the center of G, is also true. So the right option is C, B and C, and the false option is A. Thank you.